I'm gonna give everybody just a couple minutes to rejoin the stream. So if you're watching this on YouTube a little bit later, that's probably what's going on. How's it going, everybody? Sorry I had to restart the stream there for a second. Streamlabs was absolutely destroying my computer, and it was because I was exporting the stream at 2K. I guess it was at 2560, so I think that's 2K, and I guess my computer cannot handle that because my GPU was at 60% there. So seems to be running better now. We should be good here. Hope everyone's doing all right, and looking forward to getting started with the stream today. Today is going to be about optimizing or fixing, I guess, the LRU cache, which isn't working properly. So we'll see about that in just a second. How's it going, Balsa? Good to see you. Also, Dark Rogue, I saw your name pop up earlier, so good to see you as well if you're back. So basically, right now, what we have is this, and it's working okay, but it's not, because once we get to this animation, we generate so many cached outputs here that it kind of kills everything. And so that's what we're going to work on fixing today. So you can see this text just kind of turns into gibberish. And so the reason it turns into gibberish there is because the LRU cache is not working properly. So we'll see about fixing that. But if any of you were watching the previous streams and stuff before, one of the things that was not working very well was the exporting. It was pretty slow. So now if we actually launch this, and I'll do a different project so it exports a bit faster. But if we launch this and export this video, you can see that it actually goes very fast. So you can see here, I'm dropping frames here. I'm at like 40 FPS, but that's because I'm streaming at the same time. Normally it runs a bit faster, and you can see the export progress over here, and it finishes up very quickly. Can't remember if I went over this already or not, but this is kind of the current state of things. And so you can see we've got this test render output right here, and everything looks pretty good. So this is a little bit fuzzy. I got to work on increasing the fidelity on renders and stuff still. As you can see here, it kind of like normalizes the SVG heights and stuff, and I need to do a better job of that where the pixels are more representative of what they should be. So like the size here should probably be the same size that it is on the screen. So that's another thing that I've got to add that I'll be working on a little bit. But like I said before, and to anybody who's just joining, today we are going to be fixing that LRU cache. So an LRU cache is a least recently used cache, and that's what this thing over here is. So basically what's supposed to happen is as this runs, we cache the SVGs, and so we cache them into this frame buffer over here. There's actually 4 of them, and these are 4K textures. I may add more later on, or like allow you to add more. I'm kind of limiting it because I don't want to take up too much RAM and stuff. But certain animations generate a lot of intermediate SVGs, like this replacement transform. And so you can see once this starts going through and generating the different frames, we start generating a lot more intermediate SVGs. And what you can see here too is I have these red spots popping up because these are the SVGs that are actually being replaced. So since this is a least recently used cache, what it does is before it moves on to the next texture and starts filling this one up, it goes into here and it looks in the top 10% oldest entries, which are up here, and it sees if it can use one of these to store the intermediate SVG instead. So basically we do that right here. And looks like we have a not actual viewer. So give me 1 second, very quickly. And Twitch always makes this harder than it should be, I feel like. Or maybe I'm just not used to their new UI. I don't know. Okay, anyways, I'm going to ignore that message, and I'll kick that user later on. But so basically, we have this LRU cache, right? And if something gets replaced, we see it kind of pop up in red behind the letters here so that we can kind of see what's going on. And then it'll keep filling up these background spots as it goes on. And you'll notice it kind of flickers. I don't know if that's coming through over the stream and stuff, but it kind of flickers. And the reason it flickers a little bit is because what actually happens is these SVGs get generated on a separate thread, and then we basically see the final result like milliseconds after it actually runs that rasterization process. And the reason is because that's slow. And so to make sure we keep hitting 60 FPS, we want to, I think it's amortize, I don't know, the cost of the generation, where we basically want to spread out the cost over several frames so that we're not blocking the main thread and stuff. So that's kind of what's happening. Now, one of the reasons that I've gone down this rabbit hole of optimization and everything, and like where I'm getting all these ideas of where I want to optimize and stuff, I've added Optic, which is a profiler. This is what it looks like. So basically, if I launch this, I have different metrics that I'm gathering from the app itself. And so if we go into here and then we go into Optic and hit play, this is going to start generating some metrics, and we can go through and we'll just kind of play through some stuff. And then I'll hit stop so that we can kind of see what we've collected. And so then what you see is we get a big giant graph, and you can kind of see the spikes over here, the frame spikes. And these are spiking up so high because I have VSync on. It's not actually very large frame spikes, and part of the reason is also I'm streaming, so it's going to spike easier. But basically you can see we're only taking up around 11 milliseconds in the frame. So this is 9 plus, that's about 1 plus another 2 or 3. So like 13 or 14 milliseconds to do all of this. And what actually happens is these are the more expensive things. And so through a bunch of looking at profiling and stuff, I kind of find out where the hotspots were, and it was these pieces. This piece is also clearly a large hotspot because it takes up a lot of time. And so this is something else I want to optimize at some point, but just haven't gotten around to it. And so basically you can see these are all on separate threads. So these are different threads, and this is the main thread. And this is where the rasterization happens. So basically what ends up happening is you get slightly slower, or you get a slight delay before you actually see the final result. But then what happens is it kind of spreads out this cost over several frames. So you can see we keep doing more stuff here, and then we do more stuff here. And so that way we don't overload the main thread. And we keep a pretty consistent 60 FPS. So anyways, what ends up happening is after that SVG gets rasterized, it gets put into this LRU cache. And then we basically go and replace the oldest one if there's no room, or we clear out the next texture and use that to start generating some more points. But like I said at the beginning of this, it's broken. It's not working right. So if we go through here and like play through this stuff, you'll notice this is just all wrong. And then we start getting some very strange artifacts over here. So you can see all of this stuff is just wrong. I've done a lot of debugging and have not been able to pinpoint it yet. So we're going to try and pinpoint it today. And the way I'm going to start pinpointing that is by just writing some good old fashioned tests. And so a little bit earlier, I was just writing up some basic test suite code. So basically, I just added it so that now we can go through and add tests. So like unit tests, this is a test suite for the LRU cache, and we can basically just use this macro. And what it's going to do is it's going to add it to some test suite runner that's going to go and launch a bunch of different threads and run each of these as fast as it can. And then it reports the results here. So we can see I just have these set up to like return success or false, but their dummy tests don't actually do anything. So we get like success, and then we get failure, and then we get 1 out of 2 tests passed, 2 out of 2 tests passed, and then 1 out of 2 test suites passed. So I've tried to make it kind of as simple as possible, but yeah. Anyways, what I want to do though is we want to actually test the behavior of our cache, because everything looks right to me, but I think it's wrong. And so it's really hard when the code all looks right. This is the LRU cache itself. The code all looks completely fine to me, but I think it might be failing somewhere. And so adding these tests is just going to add confidence that it's not actually in here and the problem is somewhere else, and then we can kind of expand that search. So the way that this LRU cache works is it consists of an unorder map internally, and then it consists of a doubly linked list of LRU cache entries. If we look at this, it's just got a pointer to the next and the previous. And so basically what happens is we have this index lookup for fast lookup, right? If you want to get the most, just like lookup by a key, right? If you just want to find out whatever the key is for this SVG, it's fast, right? Because it's a hash map. And so if we actually look at the SVG cache, which uses an LRU cache, so caches upon caches. If we look at this, we can kind of see how the API works out. Very horribly right now, I might add, so I got to change a lot of stuff. But basically, we check and see if this exists, and this exists internal, basically just checks and sees if it's in our LRU cache. If it does not, then we need to add it. So what we do is we try and find an entry by, first of all, looking at the oldest cached entries. We look at the oldest 10% somewhere over here. And so we basically go through, if we find one that will work, we go and we evict whatever's there right now. And then after everything goes through, we basically, right here, just insert it into the LRU cache. And so the biggest part of this cache that's different than just like an unordered map is the get function. And could change more stuff and everything later. But basically what happens is when you get an item out of the cache right here, it goes and it looks and sees if it's in the cache already, and if it is, then it sets it as the newest entry. And so you kind of get this reordering of data slightly, where basically as you get items, they kind of move from the back of the queue where, oh, this was the oldest, but now you just used it, so it's the most recently used, right? And so kind of least recently used cache, it kind of swaps the data around, except since we have a doubly linked list, it doesn't really, it's just swapping some pointers, so it should be fast. And then we have the fast lookup because we have the hash map as well. So it's kind of a combination of both those. So we want to basically just test that all of this is working as it should. And yeah, we'll see what happens. And the toasty fail. How's it going? Good to see you. Okay, so now that we've got that out of the way, basically the way I write test is we go through, kind of look at something. I guess the exists function is the easiest one. And then I just write a descriptive name and we say, okay, let's test that out. So exists should return true for existing item, right? So this is the test name. It's really long, but that's because when you're looking at test results, you just kind of want to see what it is. And so this is going to see if when you call exists, it should return true if there's an actual existing item. Okay, and then what we'll do is we'll go in here, and then we will go and add in, I think it's in core. No, it's not. Utils, maybe? Yeah, okay, there we go. So we're going to go do this, and I'm just going to have a helper function up here because we're going to have to do this a lot. And let's also just make these linked. Actually, we cannot link these internally. I don't think, because I'm actually using those function pointers. Maybe. I don't know if it matters, but we're going to leave it like this. So basically, we're going to have this. This is going to return an LRU cache. We'll just have like a uint32 as the key. The value will just be a struct, which is just going to be some sort of dummy data. So we'll just have like dummy data, int, integer, and float. We'll just call that f and I. Okay. So we'll do this, keep it as simple as we can. And so this will go from here to dummy data. And then we'll have a create cache. And I'll go ahead and implement that down here. So this will be our test data. And the way we can do this, we can just say cache. And then we will just go ahead and implement that. Okay, I think that should be it. I'm actually just going to change this to auto too, so there's no sense repeating it twice. So we have the cache, and then basically we just want to insert some stuff. So we'll say insert a key. We'll actually do this at like 21. I don't know. We should probably add these as constants too, just so that we have this data available. Constant. And so we'll say like const expr int key 1 equals 1. And then we'll have like a and this will look something like that. Except I think I need to call it dummy data because that's what we called it. So we'll do that, and then this will be like 22 and 3.14. All right, so we've got key value, and we can add more. What did we say that was? Let's say that's 21. So if we add this, that should add it to our cache, and now we have some test data. And string strange 05, not related, but why do you use OpenGL for my Minecraft clone? Because I know OpenGL, so it's just the easiest. No other reason, really. Unless that question had more intent behind it, by like, I don't know, as opposed to what is, I guess, what I would ask. Like, so yeah, OpenGL is a graphics library, so framework, I guess. It's not really a library. And it's easier than Vulkan, so that's mainly why I use it. Okay, so we've got this cache, and now if we write our first test, let's see if this all works out. This is my first time using this whole kind of setup, so we'll see what happens. Setup, let's see, what did I call that? Create cache, okay. So we basically want to say bool, well, just return cache.exists, and then we can give it our key 1. That should return true. So if this doesn't return true, then our function returns false and that test fails. So let's see, and we're gonna make this true as well, just that everything's passing for now. So we run this. All right, and we've got a success. And just to make sure that this is actually behaving properly, let's go ahead and make that fail. I guess technically you're always supposed to make the test case fail first, just to make sure it's all working right. Okay, yep, so it's failing, and now when we return the actual thing that we want, it is true. So let's actually call this exists equals that, and then return exists. Maybe I'm gonna add one more macro in here just to make this a little bit more kind of like make sense what's happening. So let's just do this, like assert true value, and then this will basically just return value. I don't know, what do we want to do there? Maybe I'll do something like this. And we're gonna wrap this in its own scope just so that nothing fails. Okay. I'm just kind of making up a testing framework on the fly here, so nothing's really gonna look good right now, but yeah. So let's just say assert true exists, and then we could actually simplify this and say that, and it should work, and then we'll just return true at the end of this. And so if this fails, what we should see, so if I do that, we should see it fail, and then if I do it the other way, we should see it succeed. We'll see what happens. Okay, so we get fail, and then if I just take that out, we should get success. Cool, we get success. All right, so that's good. I'll probably throw in a few more and stuff, like where I guess we could throw in equality operations and stuff in here. We'll see what happens. I don't know, doesn't matter too much. Okay, so anyways, that kind of tests the simplest case, but let's make this a little bit more complex, and let's add some other dummy values. So we'll say like insert a few more keys and values. These I really don't care about. I just want to add some stuff. So let's actually just do for size t I equals 0 until I is less than 10. And then let's go ahead and just insert some stuff. And we want to insert random numbers. So we'll do like rand, which should give us a random number. And then I'm just going to cast that to uint32. And for this, I'll just do I and float I times 3.14f. So we'll just do multiples of pi, I guess. And this is going to be dummy data. Okay. Oh, and I have to cast that because this is expecting an int. So let's just do that as well. And that should be fine. Cool. So let's just make sure this still works. Balsa, what were you using for multiplayer? I was using a library. I think I mentioned it in the video, but I can't remember. Let's see real quick. Enet. So it's a FPS C++ multiplayer. Well, it's just like a very low level like UDP packet library. And then everything else was just kind of coded on top of that. So let's see. So we've got this. This is working good. What's the next thing I want to test? Okay, next thing I want to test is get should return the item if it exists. So let's do that. Get should return item if exists. So we'll try this one out. Okay, let's make sure that this is failing. So we'll say assert true, false, which should make us fail so that we can make it go green. Which I guess is the proper way to do things. I don't know. Okay, so we get should return, it's failing, so let's make it green now. Basically, we want to say cache equals create cache. And then we want to say cache.get key1 auto value equals that. And let's actually I don't like making this auto because this is technically a null option. And then dummy data. Okay, let's make it that. And I think that might be a reference. No, what's this returning? Optional, not null option, but an optional. Okay, so let's do that. And we should say value.hasValue. So basically this should be fine. Let's see if it works. Cool. So get is working as well. Let's also double check. Get should return null opt if item not exists. So let's try that out. And let's actually go up here. And then we will just add that down here. Okay, so for that one, okay, for that one, I guess we can just do a negative number because this is positive. These will all be positive because they're unsigned ints. Oh, wait, no, that's not going to work. Uh-oh. Okay, this is where we can't really just use random numbers. I guess we can. Okay, we're going to make this easier on ourselves. This is just going to be I, and I guess since this is 21, it should be fine. And let's just do I plus 1 so that we don't insert 0, and we'll try that out. Okay, so to make sure that it doesn't exist, we can just use like uint32 max minus 1, and that should be a value that does not exist. And so we can just assert that the value is null. So something like that. Can we not check that? Value dot. Yeah, I guess the easiest thing to do here would just to be invert this. Well, actually, instead of inverting it, I could just do this. And we will add one more helper. So that's just as easy. All right, so we got that helper now. I don't like double negatives, so this feels better to me than doing it the other way. Like assert false, this should be false, rather than assert true, this should not be true. That just feels weird. I don't know. But also, I saw on GitHub you are for some projects using CMake and some for Premake. Why don't you stick to one build system? How do you decide which build system you should use for projects? So I used Premake before, but I'm slowly switching things over to CMake because that's just what most people in C++ use, and it's a pain trying to use Premake with those things. So I've just been slowly switching over. That's why some projects are one and some are the other, but I like Premake better. CMake is it's just stupid. So, you know, there's lots of stupid things about it, but it is what it is. Okay, let's see if this works. All right, so we got our third test in there, passing. That's good. What's next? Okay, so get should promote the item to the newest entry. Get should promote item to newest entry. Basically, if you get an item and it wasn't newest before, it should now be the newest. So that's what we should get. Let's see if it's true. Basically, let's go in here. And then we'll go ahead and add this test here. Okay, and we'll say cache equals create cache. And let's do this. So this is going to be kind of hard. Basically, I was going to say okay, actually, no, this isn't going to be hard. So what we'll do is we'll say optional dummy data value equals, or I guess newest. Okay, we'll do it this way. Result equals cache.get key1. So now key1 is going to be cache.newest entry. So if we want to see if it's not the newest entry, what we can do is just say auto newest entry equals that. And what we basically want to make sure is just like that this wasn't already the newest entry. So we'll do that, and then we'll basically say assert true result does not equal old newest entry, and result does equal cache.getNewest. And then we'll return true here. Yeah, and I was wondering if this was going to work. So this returns I think this should be returning a pointer. What if I make that auto pointer? No? Okay, let's check this real quick. Yeah, this should be returning a pointer. Okay. Let's just explicitly type that here. And we'll call that uint32 dummy data. Okay. And then what we can do is we can say, okay, so I see what's happening here. Basically, we want to check and see. Trying to think of what the best way to do this. So this returns an optional. It's not returning us the actual cache entry. I guess we can just check the dummy data itself and see if it's equal. So if result, first of all, say assert true, result.hasValue, right? And then we're going to say this dot get or dot value does not equal this data. And I'm going to separate this onto a couple of new lines just to make it easier. And result dot value does equal, whoops, the newest data. Okay, so I think that should be fine. Let's see, this data should be dummy data. So that should be fine. And then this value should also be dummy data. At least I would expect it to be, but this still isn't happy. Okay, what's happening here? No operator not matches these operands. Ah, okay, it's because I see. Let's do that. And we should be good there now. Okay, there we go. Now we're getting no operator not equals matches. Dummy data does not equal dummy data. Okay, so let's add an operator real quick too, just to make sure this works. We'll say operator equals, and this returns a bool. Const dummy data ref A, const dummy data ref B. Let's just return that, and a.f equals b.f. Okay. And this must be a member function. So let's just do that. And let's also just do that and that. Why is this not happy now? Equals. I guess we should change this to just b. So we'll do that. And that. And we should be good now. Okay, cool. Let's see, does this work now? Hey, Tinspin, how's it going? Looks like we did get a pass too, so that's good. Should promote to newest entry. So that's cool. Tinspin, hey, what version of Visual Studio am I using? 2022. And have I ever had to use compatibility mode to get an exe to work on 10? If you're talking about Visual Studio 2010, I wouldn't be sure because I don't think I've ever used Visual Studio 2010. Windows 10. Okay. Yeah. No, I've never had to do that, so that's interesting. Let's just make sure this logic is sound too real quick. So we get the old newest entry, right? This is whatever's the newest entry at the moment. We get the result. So this should promote this result to be the newest entry now. We make sure that the old newest entry wasn't already this one, right? This key. Then we make sure that the newest entry now, which we're doing right here, does equal that. And it looks like this is returning true. So promoting an item to the newest entry seems to be working. That's good. There's a lot of other stuff in this get function though that we're gonna have to test now. So we've tested kind of like the basic things, which are, it should return the item if it exists. It should return null option if it doesn't exist, and then it should promote an item to the newest entry. But now we want to make sure that this pointer math is still working. So we should get the same number of items before and afterwards by traversing the pointers. So let's make sure that's working properly. And they should also equal the size. So let's also just kind of separate these out. Bools, get should reassign pointers properly. Okay. So let's do this, and then we're gonna go down here. Copy that. So we create a cache. We've got the oldest entry, or the old newest entry. Let's see, we have cache.size. Yes, we do. Okay. So first thing we'll do is we're gonna traverse size t pointer traversal size equals 0. What we're gonna do is we're gonna traverse twice. We're gonna say while, and let's actually do this. Oldest equals cache dot oldest. You say while oldest does not equal null. Oldest equals oldest next, and pointer traversal size plus plus. So we're going to kind of count how many entries we run into, and we're going to say assert true. Pointer traversal size equals cache dot size. Okay, right? Then we're going to get, so this should promote entry to the newest. And then we are going to make sure that this is still true. So we'll go ahead and we'll do this one more time. Make sure pointer traversal size still matches. After get. So let's call it that. We'll do that. And then we're going to say assert true. That equals pointer traversal size. And then we're also going to assert true. That equals cache dot size. So make sure the size didn't change, and we want to make sure that we got the same result for both of those. So let's try that out. And let's do this. Let's see what happens. Ah, okay, we're getting a failure. This is good. I thought the LRU cache was broken, but I wasn't able to prove it to myself. So if the logic is correct, this is telling us that something is actually bad. So let's actually just kind of glogger info to see what's happening. We'll go that guy, cache size, right? We'll grab those, and then we'll do this after get, and we'll print out the cache size again. Okay, let's try it out. Let's see what happens. Cool, this is good. We're making progress. Okay, so this is what we're getting. Pointer traversal size 11, cache size 11. Pointer traversal size after get is 1. I was wondering if something like this was happening, and this makes a lot of sense now. This is actually why it's broken. So let's go into our cache and see what's happening inside this get function. So basically, we use the index lookup to find out where this guy exists inside of our doubly linked list. Okay, now we have a pointer, which is a doubly linked list element. And I'm going to draw this out because this is a perfect opportunity for drawing, and it's going to help me visualize this better. So let's do that very quickly. I'm going to switch my screens over here to the drawing screen. So I know it says learning Vulkan, but that's not what we're doing today. So we can ignore that. And I'm going to go ahead and just move this to a new thing. So basically the way this LRU cache works, right, is we have a bunch of linked lists. This is the oldest linked list. It points to null that way. And then it points to the next node. And he points this way, right? And we have like basically a bunch of stuff in the middle. And then this is the newest entry, and he also points to null. Okay, so we have this linked list, but then what we also have is we have a hash map. And the hash map basically like has all sorts of different things, right? So we can basically use the hash map to index directly into this linked list. And so what we do, and sorry for my horrible handwriting, what we do is basically we look up this hash map. I'm looking at the code now so that we can kind of trace out the execution. When we get an item, so say we're getting this item, right? What we want to happen is we want him to move to the front because now he's the newest entry, and then we want this guy to point here and this guy to point there so that everything is kind of updated properly. So let's say we get him. First, we check if it's the newest entry, and if he's already the newest, we just return that because we don't have to do anything. That's not true. Next, we check if he has a next pointer. So we say, does he have a pointer pointing this way? He does. And we say if he does, then his previous pointer should now point to his previous pointer. So then we say update this arrow. Can do this in blue. So update this arrow to now point where this arrow is pointing. So we do that, and let's erase that. That's now gone. Then we check and see if I have a previous entry. I do. And if I do, if we set his next pointer to point to my next. So now he should point there. So we get rid of that. And now if we draw in blue again, we should have something that looks like that. And he's still pointing here and here. So then the last step, if I scroll down in my code a little bit, the last step, what I do is I say, set the previous, so we erase this guy, this line. The blue is still there. We set his previous to point to the newest entry. So then he goes all the way over to here. And then set his next to be null. And then his next pointer should disappear. And then we say if the newest entry exists, set the newest entries next instead of pointing to null. Set it to him. So then this guy is going to point here. Okay, it's getting kind of awkward. And this is going to point to null. And then we return it. Okay, so what happens there? So now if we follow this line, we should still be able to go. We can basically trace it. Let's go. I just want to change my color here. Okay. So if we trace this, we should go like here. We skip him. Then we go through here. And now that's gone, which I forgot to erase when I was erasing the null pointer. And if we follow it, we go here. I think I see a problem already. Okay, wait a second. So yeah, this is just going to be a loop, which isn't happening. Otherwise, we'd be in an infinite loop. So what is happening? Wait a second. Oh, wait, no, yeah, this is right. Okay. Wait, I think it's right. So we go here, and then we go through all of this stuff. Then we hit this. Oh, and I guess technically we would be traveling along this line, and then we would hit that null. So I just kind of have these looped a little bit weird. But yeah, that sounds like it should be right. Sorry if this is super confusing too. I'm just trying to work through this stuff and make sure the code's right, because right now something is definitely wrong. Let's go switch screens again. Let's put some logging stuff in here real quick. So this is the actual code, right? We basically say we get this. If it's already the newest entry, we just return the entry. Otherwise, if it has a next pointer, set the next previous to our previous. And if we have a previous, we set our previous next to our next. Then we set our previous to the newest entry, and we set our next to null pointer. And then if there's a newest entry, we set his next to be us, and we set ourselves as the newest entry. Trying to think of what would be the best way to... Let's do this. Okay, let's go into the test suite real quick. Let's go here, and we're just going to print this stuff out. So we'll say actually, I'm just going to use a string here because this will be easier. String buffer equals that. And we're going to say string buffer. And actually, let's do this. We'll say null. And then we're going to do that. And we're going to say plus equals, and this is going to go oldest key plus, and then we'll do like that to indicate that that's a doubly linked list pointing two ways, right? And so that should kind of build up our list. And then at the end of this, we'll say string buffer plus equals null. And I think that should be it. And then we'll just say glogger info. Okay, let's see what happens here. So I'm just trying to print some debug stuff out, and I think this will help us out. If we actually print out the string. So let's just call this C string and see what we get here. Okay, there we go. So something weird is happening here. Not quite sure why I'm getting this. Yeah, that's interesting. Okay, so we get null though. We should be getting, maybe I'm printing the wrong thing here. What's this? This key should just be a uint32. Oh, maybe I should, it's probably doing some sort of weird pointer math. Okay, let's do that. To strings, so that this is actually concatenating strings and not pointers or something. Let's try this one more time. There we go. Okay, this is what I was expecting. So what we get is kind of like a visual representation of our doubly linked list. We have null at the end, then we have 21, which if we look at how we're setting it up, we set 21 as the first one, so that makes sense. And then we insert 1 through 10. And so we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 10 points to null. And so I guess technically if we want to be pedantic and make this print correctly, that 10 shouldn't be a doubly linked list. So let's do this. We'll say if oldest next string buffer plus equals that. Else string buffer plus equals null. Okay, so we'll do that instead of that. And now we should get it all correct. And then we're gonna do the same thing and see what happens. Okay, so yep, 10 goes to null, and then we get an extra null there because of this guy, which we can get rid of. Okay, so what I'm gonna do is after we print it and we do all this update stuff, let's do string buffer equals that, and then we're gonna do the same thing. Well, I guess I should set it to that null thing. So we'll do that in a second. So we'll do that. This should actually be null, like that. And then we're gonna say glogger info %s string buffer dot c string. Okay, so let's see what it is after we do the get operation. It should be the same, except with the 21 at the front now. But I don't think that's what we're gonna see. Yeah, okay, so this is the problem. So something weird's going on. Basically, we get the 21, we get 1 through 10. What should happen is after we do all this, we should get the 21 at the end, but now we just have 21 in our entry list thing. So why is that happening? That's what I want to know. So what do we do here? We say, let's see the exact sequence of calls again. So we check the cache size, which is literally just returning a size. So that shouldn't change anything. Then we do this get operation. This is the only thing that would change something. We check if it exists. Exists doesn't do anything special. If it does exist, what do? We iterate, right? Okay, so first we find the key. Okay, that should give us an entry. If this is the newest, then we just return that. Otherwise, oh, you know what? This is the oldest entry. I wonder if there's a bug. Yeah, there is a bug. We're not checking. So, okay, I see now. If entry equals oldest entry. Yeah. Okay. Let's see if this fixes it first. And if it does, I'll explain what just happened there. The one stupid edge case that I didn't think about, and I bet you this is probably what's causing the whole app to be so buggy and weird. Man, yeah, okay. Look at that. We got 5 out of 5 tests passed now. You know what? I should quit programming because I don't know what I'm doing clearly. Okay, so look, now we're getting it correctly, right? Since this is an LRU cache, the 21 should move to the front of the cache after we get it. And now we can see that it's clearly doing the correct thing. Why wasn't it working before though? Why does doing this fix it? Let's think about that real quick. How am I traversing through the cache? If we go back into here, I'm traversing through it by getting the oldest cache entry. If we never set the oldest cache entry to be the next thing in the list, and it's still pointing to that 21, what ends up happening when we do this again is it basically goes through and it starts at the front of the list, right? So basically what's happening now is it's just starting. So this 21 has actually been moved up to here, but now it thinks that the oldest entry in the list starts here. And so it's broken because now it's not actually pointing to the beginning of the list. So let's see what happens now. I'm curious. We've got this. This is working now. Let's make the test a little bit nicer by cleaning some of this stuff up. Static void print cache. We'll do this, and then I'll just kind of add a method in here so that we can do this for testing stuff when we want to. And we'll basically just go ahead and copy this and then modify it slightly. So we don't need this. We do need this. Let's also just do UN32 dummy data. This is actually just a U cache. Okay. And I probably don't want that to be mutable, so we'll do this. And we'll change this. And I'm going to add in a couple of helpers that will make this possible. So let's just go down to where I have these defined. Okay, and then we're going to add in const and const there, const here. Whoops. And actually, these are technically const as well. So let's mark those as const. Yeah, cool. So now we should be able to use that to get const references instead. And if we go back into here, that's happy now. We can get rid of that. And that should print it. Cool. So now if we do that, get rid of that. Just want to make sure this works because I have a feeling I'll probably have to use this in the future too. Print cache. And we'll give it the cache. So we'll just do that. Get rid of this. Get rid of this. And we will print it right there too. Let's see if this all still works out. And then if it does, we can move on and see if we've actually fixed the bug in the main application. I'm usually not a big fan of tests, but there are certain cases where the tests are very useful, and this one is definitely included. Okay, so it looks like everything's still working right, so we can still visualize this stuff when we're testing if we need to, which should be nice. So let's go ahead and get rid of all this debug info. Now that we know everything is actually working, let's just make sure we've actually cleaned this up properly. And we do. Cool. So we got passing tests. We're good. Let's go back into our main app, which is this one, and let's see if we get weird stuff happening. All right. I'm excited. This bug has been causing me trouble for like the longest time because I just didn't think about this edge case. All right, so we've got this in here. Okay, so yeah, you can see these are all turning red, and that's just for debug. I'll turn that off afterwards, but it's just that we can actually see where it's kind of reusing those cached entries. But it does look like it's working. That T pops in at the end there, but that's just that's a different bug that we have to fix. So, you know, get around to that eventually. But I think we fixed the overall bug, which is very good. So let's just run this real quick, make sure it all kind of works. And so you see there, we didn't really see the animation play out, and that's because that slight millisecond delay while those things are running on the background thread means we won't actually end up seeing it, which is unfortunate, but I have plans to get around that and stuff. So we'll work on that another time. This looks like it's working though. I'm pretty happy with the way this is going. If we just go back through here, so now that those are cached, we'll actually see the animation play out. Yeah, and we're getting those red. Yeah, we're getting that red stuff because of the way the caching is working. But after it kind of goes through and caches all those entries, we can actually see them pop up here with some slight artifacts because we're clearing the background color weird. Cool. I'm pretty happy with that. Let's go ahead and, first of all, let's do git add animations / tests / get status. Nope, that didn't work because that should be lowercase. Okay, there we go. So we'll say commit update LRU cache test. We'll finish writing the test too because I think after finding that bug, it's important that this piece of code is definitely thoroughly tested. Let's just go ahead and add that though for now. Oh, and let's actually add in the updates to the unit testing framework too. So we'll say git add star test. Nope. Nope, that's not gonna work. We'll add them manually then. Okay, core include / core. Nope, that's not matching anything either. I am mistyping like crazy today. Let's add an I there. Okay. Let's go update testing framework. And then we'll add that last file. Fix bug in LRU cache. All right, and now let's change the clear color again because we no longer need that kind of debugging information there. So let's go into this guy and I can just change that. All right, so let's play through the animation one more time, make sure everything's working all right. So we click onto here. We'll go back to the beginning of the animation. Play through this again and see what happens. Okay, we don't really see it play out because of issues. So one thing I should mention, when we're going through this, if I just play this manually, we're not going to see the animation because of things I have to fix. But when I export, what I do is I make sure that this does not run asynchronously. So if we actually take a look in here, if we're exporting the video, this runs synchronously. Otherwise, if we're editing, it runs asynchronously. So what that means is if we export this, I should see a properly exported video. So let's do this real quick. I have no idea how my computer is going to respond to this because it does use quite a bit of RAM, and I've been hitting page swapping. So the stream might kind of go down or something. I don't know, or slow down significantly. We'll see what happens. So we're going to export it real quickly. And the reason it starts page swapping and stuff, this is actually kind of interesting. So you'll notice too, this uses up a lot of stuff. But if we actually look at the memory, we're still using less RAM than like Visual Studio and Visual Studio Code, except that's actually a lie. we're not actually just using 2.5 gigabytes of RAM here. We're using a lot more, but I'm memory mapping a file. And so what Windows does is if you memory map a file, instead of actually counting that towards your program's used RAM, it just kind of doesn't. And then it does a bunch of stuff, operating system stuff, where basically like it tries to keep that memory in RAM. And then if it needs to, it actually starts like placing it on disk. And that's why the frames are now dropping to 10 FPS, is because now we're writing to disk and it's slowing things down. But if you have enough RAM, it kind of silently uses that RAM, and then you don't actually slow down at all. So, and I think part of the reason this is extra slow too is because I'm also streaming here. Usually I get like 40 to 50 FPS during the export. So regardless though, this is still way faster than it was when I was using FFmpeg, and it was much, much slower for the most part there. Okay, and we're almost there. 93% of the way through. Very close. I'm also glad I added this progress bar, because otherwise you're sitting there for a long time wondering when the export's actually going to finish, and this makes it a lot easier. Okay, cool. So now it's done. We're back up to 60 FPS. If we go into our videos, I keep clicking the wrong one there. We have an exported video here, and if we take a look at it, it should play back the animation properly. So starts up here. Everything's looking pretty good. Okay, so that is kind of sus, I'm not gonna lie. Don't know if you guys can tell, but it's definitely blinking for a second there. Like everything kind of blinks out of existence. And so what I think is happening is I think basically our cache doesn't actually have enough room for everything. And so for one frame, something is getting evicted that shouldn't be, and then it's not actually rendering right. And so that's where our next fix is going to come in. But I'm going to wait for a second, and we'll talk about that afterwards, because that's not really part of it. For the rest of this, though, it's going pretty good. No problems there. I'll just skip through kind of towards the end. Yeah, and that looks pretty smooth and works out good. Cool. Okay. So the exporting is working properly. The one thing we have to fix now is every now and then there will be a blink, and the blink happens because everything gets evicted and there's no room left in here. And so basically what's happening here is this fills up with a lot of very similar things, right? So every frame of this animation, what I'm doing is I'm creating a new SVG here. And this SVG is like the interpolation between whatever this is and what it's turning into. And so if we actually just zoom in a little bit here, you can kind of see that morph, right? It slowly morphs into the second letter. And there's some artifacts and stuff, but when it goes fast enough, you don't notice it too bad. But if we look over here, what we'll notice is like the letter T, for instance, from this frame and this frame basically looks exactly the same. And so since it looks exactly the same, what I kind of want to do is if we zoom in the timeline here, and I'll move this over here. Okay. So basically what I want to do is I want to take like, we'll take a snapshot of several keyframes, right? We'll get this keyframe, and then like maybe 10 frames later, we'll get this one. And you'll notice this looks almost exactly the same between this frame and this frame. Like nothing's really changed. And if we go like a few more frames out, then it starts really changing, right? And then a few more frames, starts changing more. A few more frames, starts changing more. And so what I want to do is I basically want to capture some of those keyframes where we'll capture like right here, 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 so on and so forth, and we'll only capture like 10 or 12 of them. And then we can interpolate between the textures, which means that we should only get 10 or 12 copies of each of these letters. And that should hopefully make sure that the cache never gets overflowed. Yeah. And so that's kind of like what I'm thinking in order to fix this. That's going to be pretty involved though. And I'm not sure how I'm going to approach it. For now though, this is, I'm pretty happy with the way this is at. One last thing I'll do too real quick. I think I'm going to end out the stream, by the way, here in a few minutes. But one last thing I'll do is just kind of show if we switch to release mode without the profiler and we go into the application and we turn VSync off, just so that you guys can kind of see, like, I've done a lot of work to make this as fast as I possibly can. And basically what we end up getting is around 700 FPS, and then when it drops, it goes to like 200 FPS. So it's still going really fast. Like basically for the most part, most frames only take 4 milliseconds. I'm not sure how fast it's gonna run with Streamlabs running and actively streaming stuff, but we'll see what happens. But yeah, once we get this out of the way though, I am going to be much more confident in the performance of this application. I still have to test it on older laptops and stuff and see where the bottlenecks are. And I already kind of know, as I showed you guys earlier in the stream, where the rest of those bottlenecks live. So have to work through those at some point. And I've got some ideas, but nothing concrete yet. The one thing I will say is every time I try and optimize something, it is very surprising where the bottlenecks are. They are never quite where you expect. In this case, I was mostly right. I knew they were going to be in that replacement transform was going to be the biggest bottleneck. But outside of that, there is a lot of optimization areas that I would have never expected, which was interesting. So if we go into here, looks like I'm getting around 630 FPS and we're taking about 2 milliseconds. It says 0.002 milliseconds because I'm dumb and I haven't changed this text to actually say like, this is just 2 milliseconds. I'll have to fix that. But if we actually go ahead and play this, you'll see that we keep a pretty steady frame rate here. We're dropping to like 300 there for a few frames. When we hit this animation, we're going to drop a lot more, but we only dropped to 200 frames per second, right? And that's like the heaviest part of this animation. That's where it's going to be like the hardest hitting. And so the fact that we're only dropping to 200 while I'm also streaming with VSync off shows that this is really, for the most part, pretty good, right? And you can see here we average around 400 to 500. Well, actually like 500 to 600 is probably a little bit better. But yeah, so it's performing very well. And with VSync on, you'll see that our bottleneck is now not actually the CPU, but the GPU, where we're using 88% here and only 25% here. So I guess like the next step, if I want to optimize this further, we're getting 2 milliseconds per frame. So I don't think it's necessary to optimize it further. But if I wanted to, it would be to like streamline the GPU processing and stuff and basically make sure that we're caching data where possible on the GPU as well. But yeah, it doesn't seem necessary. And if we actually go through, you can see everything is just a lot faster. And if I go to a different scene, let's go, yeah, we'll go in here. So this is just a small scene, I guess. Really doesn't have anything in there. Let's go to a different one. This one maybe? Nope, that one's got nothing. Yeah. You can see like loading in new scenes and stuff, we drop to like 300 FPS, but for the most part, it stays at around 2 milliseconds per frame and doesn't really change, which is nice. This one's kind of interesting too, because I don't know why I have this square here too, but oh, let me go in here. Square bracket is not looking right. Let's just delete that. Okay. And if we play this, we can see we are averaging, if I go back to the beginning. Okay, so we dropped a little bit, like moving backwards, which is also to be expected. It's like the other thing that takes up a lot of performance is when you're actually moving through the timeline, but we're still maintaining around 140 FPS. So that's not too bad. I'm pretty happy with that. Yeah, cool. So I hope you guys enjoyed this. Glad we fixed the caching issues. So now this is actually working properly and using a least recently used cache as it should be used. But yeah, one other optimization I made too, which I forgot to mention, is now you'll notice that the letters are actually being reused here. So like these letters, let's see, they're cached right here. And you'll notice they're only cached once. So basically, I'm taking the MD5, which is usually used for a checksum. I'm going to take this down because vsync off is just using up my entire system. One of the optimizations I'm doing, basically, is each SVG now has associated with it an MD5. And the MD5 is the MD5 of its actual path. And the reason for that is, and I guess I should probably change this because technically an SVG object could have multiple paths, so that's gonna have to change. Yeah, but the reason for this is so that we can reuse like similar SVGs, right? If you have the letter A twice, you want to reuse the letter A. You don't want to actually have 2 entries in the cache. And so now I use this to actually make sure we're deduplicating stuff and everything, which has also helped tremendously. But yeah, I hope you guys enjoyed it. I'll probably stream next week, and hopefully we'll have more progress and be working on some more interesting things. But yeah, I'll see you guys then.